about it later in the week. The first thing that I'm going to do is I'm going to bring up the multi-buffering table, and I'm going to set each one of these to 2. And so instead of single buffering the processing, I'm going to double buffer it. So I'm going to be bringing data in 2 buffers out of memory rather than 1. The other thing that I'm going to do...
So you can process in parallel with fetching memory.
Right, so I'm going to be fetching the next data set at the same time I'm processing the current data set. And well, I'm going to do one other thing in order to improve the throughput, and that's that I'm going to change the mapping. Because if I look at the configuration view of the hardware that's available, 100 through 102 are SPUs. 120 through 125 are SPU SALs, which are used in the Mercury Computers optimized library called SAL, Scientific Application Library. So I'm going to change the mapping to equal to 120 plus $1, and I've now got 120 through 123 instead of 100 through 103. And I'm going to save these group settings. Just I'll save them as this.
Just a comment, I mean, it's going to be running on the same processors. The only difference is it's going to be linking in the Mercury library.
That's right. That's only a difference between these 2 processor types is the library that's getting linked in. So I'll now run this application, and we'll wait until it actually starts running once again. You notice it had to rebuild the application because each time we do this, we're changing the architecture of the software, and it has to be re-implemented. So now we're running the application, and once again we'll terminate it, and now you can see that we went from 3.2 up to 52 gigaflops. So this is a pretty good number in terms of the amount of processing. On 4 SPEs, the theoretical maximum is 102 gigaflops, and we're achieving 52 on this application, which is not particularly well balanced in terms of adds and multiplies. We've got a vector multiply, which is 1 multiplied to 0 adds, and we've got FFTs, which are some ratio not quite 1 to 1 for multiplies to adds. And I can never remember what the ratio is. 5 to 4?
5 to 1 or something.
5 to 1?
Something.
Yeah.
That's why it's 5 order and long ends.
Yeah. So in any case, this is a pretty good result, and you can see in the amount of time that we spent here, which has been maybe 20 minutes?
21:47.
What's that?
21:47.
21:47. So in 20 minutes, we're able to achieve 52 megaflops on a processor like the SAL, which is actually a pretty good number to achieve.